Algebra 2, Quadratic and Absolute Value Transformations. This is Teacher Talk concept number 5. So in this Teacher Talk, we're going to review the notes that you took. We're going to review the transformations to a quadratic equation. So you want to remember the general form of a quadratic equation, and this is vertex form. So g of x equals a times x minus h squared plus k. What we're concerned with is those parameters a, h, and k. So the a value, if it's negative, will make the graph of our quadratic be a reflection across the x-axis. And then if it is greater than 1, we'll have a stretch, and if it is less than 1, then we'll have a compress. The h value will shift our quadratic left and right. And remember, it's opposite of what you would think. So if you subtract an h value, you're shifting right. If you add an h value, you're actually shifting, the graph is shifting left. And then the k value will cause the graph from the parent function location to move either up if the k value is added or down if the k value is subtracted. So in these first problems, we're going to write a function g for each transformation from f of x equals x minus 3 squared. So you can see that f of x function, it's a quadratic and it has already been transformed. It has been shifted 3 to the right. So we're going to start with this equation, and number 1, we're going to translate it 2 units to the left. So that means that we're going to focus on an h value and we're going to add 2. So we take the function and we name it our new transformed function, which is g of x. And then right in by the x minus 3, we're going to add 2. So we're going to introduce another h value. Now we'll simplify within the parentheses. So that becomes x minus 1 squared. So this quadratic function g of x will be a shift 2 to the left of x minus 3. Number 2, we're going to go back to that f of x function and create a vertical stretch by 2. So that means we're going to introduce an a value. And so that will be a multiplier just out front of the parentheses. We don't distribute across the parentheses. It just sits out front. So g of x is now a vertical stretch by 2. Number 3, a translation up 5 and left 2. So up, we need to add 5 in our k value position. And then to shift left 2 again, that will be our h value where we are adding 2. So go back to your f of x function. That's where we'll start. Our new function is g of x. So right in by the x minus 3, we will add 2, which we've already done earlier. So that will become x minus 1 squared. And then at the end of the function, in the k value position, we will put a plus 5. Number 4, a reflection over the x-axis. So that means our a value will need to be a negative 1, so a multiplier of negative 1. So our new function is negative, and I don't need to write the 1, and the multiplier just stays out front, x minus 3 squared. Now let's look at number 6. So we need to write an equation for and graph an absolute value function that was reflected across the x-axis and moved down 3 units. So let's start with just a parent absolute value function. F of x equals the absolute value of x. Now for a reflection across the x-axis, we need to introduce an a value of negative 1. And to move the graph down 3, that's a k value of negative 3. So now let's write our new function, g of x, putting the negative 1 multiplier out front of the absolute value of x, and we don't need to write the 1, and then at minus 3 outside of the absolute value. Now when you graph, always draw an xy axis, label it, and label a scale. I just usually label a scale with 1 number on each axis, and I usually label the 5. Now remember the parent function of an absolute value graph is that it goes through the origin. It's a V-shaped graph, and the slope of the 2 sides are up 1 and over 1. So I have sketched in the parent function. From there, I'm going to graph my new graph. So I need to know that this graph will be reflected over the x-axis, and my vertex will be shifted down 3. So that's where I'll start, and then I'll go over 1. But in this time, instead of going up 1, I'll go down 1 on each side. And so that's the graph of our new function. All right, this concludes Teacher Talk Concept 5.